Alright, so we're going to be doing the Quadratics Part 2 study guide. Here we go. The first one has you answering 3 questions about the following equation. So the equation, so this is number 1. The equation is y equals negative 4x squared plus 8x plus 3. So the first thing it has you doing is finding the Y-intercept. Well, we know that for a Y-intercept, that the x must be 0. So we're going to take this equation, we're going to take the x out and put in a 0. So negative 4 times 0 squared plus 8 times 0 plus 3. If we do our order of operations, we end up with a 3. So the y-intercept is located at 0, 3. Part B wants to find out what is the vertex. And for the vertex, we have a formula for that, and this one we have to have memorized by test day. And the vertex formula is negative b over 2a. And what this is the a and the b and the c all come from this equation. When we are in what's called standard form, standard form is y equals ax squared plus bx plus c. So the a is your number in front of x squared, the b is the number in front of x, and the c is the number all by itself. So for this scenario, a would equal negative 4, b would equal positive 8, and c would equal positive 3. So when we plug it into the formula, negative b, so if b is 8, negative b is negative 8, over 2 times a, which a is a negative 4, you get negative 8 over negative 8, which gives you a positive 1. Now the question becomes, well, what does that 1 actually represent? Because the vertex is a point on a picture, and that's just one number. So one of the tricks that we talked about is that vertex ends in an x value, or vertex ends in the letter x, which means it gives you the x value. So what we have is the vertex is located at 1 comma something. So we need to get the y value. So we do what we've always done. To get y values, when you know x values, we just plug them in. And we did that way back at the beginning of the school year. So let's plug 1 into the formula of the equation. So we get y equals negative 4 times 1 squared plus 8 times 1 plus 3, which gives us y equals, remember, we've got to do the order of operations. So you have to do 1 squared first, which is 1. So you have negative 4 times 1 plus 8 times 1 plus 3. Now we can do the multiplication. So we get negative 4 plus 8 plus 3, in which in turn is going to give us a positive 7. So now we have the y value of the vertex. It is a positive 7. Then part C wants to know what the X-Intercept, oh no, part C, does it open up or down? And remember, this all comes from the a value. So when you're in standard form of y equals ax squared plus bx plus c, the a number is going to decide the direction. And the reason it's the a is because the x squared is what's making this curve. So the number with the x squared directs the curve to go up or to go down. If a is positive, then you're going to open up and make what we call in class a smiley face. If a is a negative number, then it's going to open down and make a frowny face. So in this scenario, we said that a was worth, I believe we wrote it up here. Yes, a is a negative 4. So since a is a negative 4, it's going to make a frowny face, which means we are opening down. On to question 2. Question 2, again we're in standard form, x squared plus 6x plus 9. Question number 1, or part A, wants to know the y-intercept. Well, again, for y-intercept, the x is a 0. So we're going to take this equation, turn the x into 0. So 0 squared plus 6 times 0 plus 9, which gives us a final answer of 9. So our y-intercept is 0, 9. B wants the x-intercept. Now, x-intercept is the exact opposite. Instead of the x being 0, if we're looking for x, that means the y is 0. So we take our equation, we make the y equal to 0. So 0 equals x squared plus 6x plus 9. Now here's where we got to do some work. Because we have x squareds and x's, you can't play the game of opposites. So you have three options. We can factor, we can do the quad formula, or you can complete the square. We want to pick the easiest, so we always look for factoring. So if we could factor, this is a diamond, we're looking for what would add to give you 6 and multiply to give you a 9. And there are two numbers that do that, 3 and 3. So 0 is equal to x plus 3 times x plus 3. Well, if that's the case, what plus 3 gives you your 0? Well, that would be a negative 3. Same thing over here. So in this case, our x-intercept is negative 3 comma 0. And you don't write it twice. Even though the number showed up twice, we only write it once. So negative 3, 0 would be the x-intercept for this problem. All right, part C wants to know the vertex. So again, vertex is negative b over 2a. So if we go back and look at the equation, our a value is a 1, and our b value is a 6. So a is equal to 1, b is equal to 6. So therefore, negative b would be negative 6 over 2 times a, 2 times 1, and we get a negative 3. Now again, this negative 3, because this is the vertex formula, that's going to be your x value. So to get a y value, we're going to take our negative 3 and plug it into the equation. So we're going to have y equals negative 3 squared plus 6 times negative 3 plus 9. Do our order of operations. We do exponents first. Negative 3 times negative 3 is positive 9. Now we do multiplication. So this is 9 minus 18 plus 9. Now we do our addition and subtraction. 9 minus 18 is negative 9. Negative 9 plus 9 is 0. And now you have the y value of 0. Last question was part D. Asked, does it open up or down? Well, because the a is positive, this opens up. So it would make a smiley face. Number 3, ask for other names that we can use for x-intercepts. You only need to know one of these. However, the two most important ones that we know for our state exam are roots and zeros. The other two names, obviously, x-intercepts, and finally solutions. These are all the exact same thing. They are just synonyms for one another. We use them interchangeably throughout our math courses. So the ones you're most familiar with seeing are x-intercepts and solutions. Roots and zeros are the newer ones that we haven't worked with as much, but we do use those words. All right, number 4. Number 4, you're going to have to look at your picture, because I cannot draw this picture on the screen. Number 4, there's statements underneath it, and it says which ones are true, and it says select all that apply. So the first statement says the graph has a y-intercept at 0, 5. That is not true, because the first one, if we look at the y-intercept, it's really at 0, negative 5. So first box is not checked. Second box says it has a relative maximum at negative 3, 4. That is true, because on your picture, the max point is the top, and the coordinates on your graph are at negative 3, 4. So the second box is good. The third statement says it has an x-intercept at 1, 0. It does not. If we look at the picture, the x-intercepts are at negative 5 and negative 1. So it does not have the x-intercept at positive 1. The fourth statement says the y-axis is a line of symmetry. Well, we know that's not true because the line of symmetry has to go through your vertex. And if it goes through the vertex, that means the equation of this line is the x value. So x equals -3. That is your axis of symmetry. So the fourth box is not going to get checked either. Let's see if the fifth box works. The fifth one says it has zeros at -5 and -1. Well, remember zeros, we just talked about it. It's another name for x-intercepts. And that's true, because we just said the x-intercepts were -5 and -1. So we definitely put a check in the fourth box. And then the fifth box, it says this graph is the function x squared minus 6x minus 5. So to do this one, we're going to have to do a little bit of work, but let's do the easy steps first. We know that if we're in standard form, our last number is the y-intercept. And if you look at your picture, we said the y-intercept is a -5. So far, so good. Now what we want to do is either we could find the x-intercepts or we could find the vertex. Let's find the vertex. So the vertex is -b over 2a. So since b is equal to -6, negative b would be a +6 over 2 times a, which is a 1. So that gives you 3. So that means the x-coordinate of the vertex is 3. Well, we can stop right there. Because if we look up here, the vertex x value was a -3. This is saying from the equation it should be a +3. So this equation does not work in this problem. So only the second and the fifth box gets checked. Alright, moving on to the next question. Now again, on my exam, I kind of lead you through how to graph by telling you what points to find. This is one thing that you'll just have to know on the state exam of all the steps of what points to find. So we have g of x is equal to x minus 3 squared minus 4. Now remember, this is called vertex form. And vertex form is y equals a x minus h squared plus k, with your vertex being the h comma k values. So the first thing that we do when we're in vertex form is we find the vertex. So the vertex is located at not -3, but +3. Because in our formula, there's a minus sign here, so that tells you to use the opposite value that you see for your x value. The y value is a -4, so 3 comma -4. The next thing that we have to find is our y-intercept. So we do what we've always done. To find a y-intercept, the x's turn into zeros. So we would say g of 0 is equal to 0 minus 3 squared minus 4. G of 0, let's do subtraction first, so 0 minus 3 is -3, so -3 squared minus 4. Now we do our exponents. G of 0 is equal to 9 minus 4, so G of 0 is equal to 5. So your y-intercept is located at 0, 5. Then we are told to find the x-intercepts. Well, for the x-intercepts, we know that the y is 0. And this is where people get confused. They go, well, there's no y in the problem. Well, remember, g of x is the exact same thing as a y. This is just called function notation. But it really is just a big fancy y. So if you want to rewrite it, and some people do that, they want to rewrite it as y equals x minus 3 squared minus 4. If that's more helpful to you, then do that. So now to get the x-intercept, that y turns into a 0. So 0 equals x minus 3 squared minus 4. Now we just have to figure out what x is. And we don't have to do anything special because you just have an x only. So we're just going to play the game of opposites. We only do those extra 3 steps of either completing the square, quad formula, or factoring when you have x's and x squareds. But this is just an x. So a game of opposites, all we got to do. So get rid of that minus 4. We add 4 to both sides. So I have 4 equals x minus 3 squared. Now to get rid of the squared, we're going to take the square root of each side. Now remember, this gives you a positive 2, because 2 times 2 is a 4. Also a negative 2, because negative 2 times negative 2 is a 4. So plus minus 2 is equal to x minus 3. So now we have to get rid of that minus 3, so we add 3. But remember, you're not adding 3 to just one number, you're adding it to two numbers. You're doing positive 2 plus 3, and you're doing negative 2 plus 3. So you get an answer of 5 and 1. So those are your x-intercepts, 5, 0, and 1, 0. So then part D says graph it. So I'm going to let you do that on your own. So all you do is you graph these points, and then you'll have to find the partner point of the y-intercept. Because the y-intercept is 3 units from the axis of symmetry. So you have an axis of symmetry going down. You got a y-intercept that's 3 to the left. That's going to be where your y-intercept is. So that means the extra point you need to find is a point that's 3 to the right. And on your graph, that actually ends up being 1, 2, 3, 4, 5. It ends up being 6, 5. So that's the extra point you'd have to find using the axis of symmetry, 6, 5. All right, number 6, simplifying square roots. So square root 44. Remember, this is where you turn it into another multiplication problem, but you have to use a number that you know the square root of. So if I did 2 times 22, that does give me 44, but I don't know what the square root of 2 is, nor do I know the square root of 22, so that didn't get me anywhere. So then we try another combo, like 4 times 11. 4 times 11 is 44, and I know what the square root of 4 is. The square root of 4 is 2. So this is 2 times the square root of 11, but we just really write it as 2 root 11. But if you want to put the dot, you can. The way you check that is type it in on a calculator. And you'll get the same answer whether you type square root 44 or 2 times the square root of 11. 7, we have the square root of 120. So again, I'm going to break it down and look for numbers that go into 120 that I know the square roots of. And again, the numbers that you know the square roots of are your perfect squares. So 4, 9, 16, 25, 36, and so on. So out of all these numbers, I know 4 will go into it, because 4 times 30 gives me 120. Square root of 4 is 2, so 2 square root 30. Now, it doesn't mean I'm done. When you do it once, you have to look at 30 and now see if any of these numbers go into 30, which none of them do. So we are actually done on this one, but sometimes you can do the process one more time, just like when you reduce a fraction. All right, solving for variables. If you have just x or just x squared, you're going to do the game of opposites. If you mix x and x squared, you are either going to factor the quadratic formula or complete the square. So when you solve these, always identify what you're starting with, so that way you can decide how to solve. So here we go. The first one is v squared equals 81. Well, since I only have v squareds, I'm playing the game of opposites. So the opposite of squaring is 2 square root. What you have to be careful of when you take the square root of 81, it's 9, but it's also negative 9. Because 9 times 9 equals 81. A negative 9 times negative 9 is also 81. So we put the plus minus sign in front. Nice and easy. Number 9. We have j squared minus 2j minus 35 equals 0. So we're mixing j squareds and j's. So the first thing I'm going to try to do, because it's the quickest, is to factor. So we go through our factoring rules, and this is a diamond factor. We're looking for what adds to give you negative 2 and multiplies to give you a negative 35. And there are 2 numbers that would make that work, a negative 7 and a positive 5. Now those aren't the answers. That's just how we rewrite this in factored form. j minus 7 times j plus 5 is equal to 0. Now we can get the answers, because it's saying this parentheses times this parentheses is 0. So either this parentheses had to be 0, or this parentheses had to be 0. Well, now you got something you can solve. Add 7 to both sides, so you get 7. Subtract 5 from both sides, and you get negative 5. Number 10, we have 4c squared plus 20 equals 11. Yeah, 4c squared plus 20 equals 11. So again, just c squares. So we're going to play the game of opposites. So let's get rid of that 20 by subtracting it. So we have 4c squared equals 11 minus 20, which is negative 9. Divide each side by 4. So c squared equals negative 9/4. To undo squaring, we square root, and this is when we have no solution, because you cannot take the square root of a negative. So we write no solution. Number 11, we have 3x squared plus 5x minus 10 equals 0. So, x squareds and x's, so we're going to try to factor first. Factoring, though, will not work. We'd have to use the big diamond, which would mean what adds to give you a 5, but multiplies to give you a negative 30, and there aren't any numbers that actually make that work. So factoring is off the table, unfortunately, because that's always the quickest. So therefore, we move into the quadratic formula, which you do have to have memorized by test day. The quadratic formula is negative b plus minus square root b squared minus 4ac all over 2a. So we come over here, our a is a 3, our b is a 5, and our c is a negative 10. So the first thing we do is just plug everything in. So negative 5 plus minus square root 5 squared minus 4 times a, which is a 3, times c, which is a negative 10, all over 2 times a, which is 2 times 3. Next thing we want to do is order of operations. So we start with the grouping symbol, which is the root sign. So under the root sign, we have exponents, subtraction, and multiplication. Exponents comes first in order of operations. So 5 squared is 25. Then would come the multiplication part. And when I multiply, I like to use the minus sign right away. So I have a negative 4 times a 3 times a negative 10, which gives me a positive 120. And since it's a positive 120, I write plus 120. If it would have been negative 120, I would have written subtract 120. So now we do 25 plus 120, which gives us 145. So now let's take a look at where we're at. We now have negative 5 plus minus the square root of 145 over 2 times a. And let's finally just do the 2 times a. 2 times a ended up 2 times 3, so that is a 6. Now, at this point in the directions, I didn't tell you to round your answers, so you could leave it just like this in root form. However, if you did it on a calculator, your two answers rounded would have been 1.17 and negative 2.84. And that's if you round it to the nearest hundredth. And on the test, if I don't tell you to round, then you can leave it just like this. All right, number 12. We have x squared plus 11 equals negative 12x. So x squareds, x's, that means we have to factor, or try to factor. But before we can do that, something's different. Normally these are equal to 0, and this one isn't, so we have to fix that. We have to make the equation equal 0. So to get a 0 over here, we could add 12x, because they would cancel. Add 12x to the other side. So now we have x squared plus 12x plus 11 equals 0. Now we're set up to factor. So this is a diamond again. What adds to give me 12 but would multiply to give me 11? Well, there's only one way to multiply to get 11 with whole numbers. That's an 11 and a 1, which if we did 11 plus 1, that would also give me the 12. So this parentheses times this parentheses is 0. If the answer is 0 and it's multiplication, that means you had to multiply with the 0. So either this parentheses gave me a 0, or this parentheses was the 0. So we solve for both of them, and we get our two answers, negative 11 and negative 1. On to 13. We have 3g minus 17 is equal to 0. Just regular g, so we just play the game of opposites. So we're going to add 17 to both sides. So 3g equals 17. We're then going to divide both sides by 3. And we get g is equal to 17 over 3. 14. We have h plus 9 times 2h minus 5 times h minus 321 is equal to 0. So again, we have just h's, so we're going to play the game of opposites. And if we look at this, this is one that's been done, most of the work's been done for us. So when they multiplied, the answer was 0. So either this parentheses was your 0, or maybe it was this parentheses that was your 0, or maybe it was the last one that was your 0. So now we can solve. Subtract 9 on this one to get a negative 9. This one we would have to add 5 first, then we divide by the 2, so we get 5 halves. This one we add 321, and so we get 321. So 321, 5 halves, and negative 9 are your answers. Uh, 15. We have x squared plus 8x plus something. We are making what are called perfect square trinomials. And we talked in class that if you are a perfect square trinomial, two things have to occur. The first and last have to be perfect squares. The middle term is twice the perfect squares multiplied. So for example, let me start off with one before we complete one. If I had x squared plus 20x plus 100, this would be a perfect square trinomial because the first term has a perfect square, which is x. The last term has a perfect square, which is 10. And if I do x times 10 and then double it, I end up with a 20x, which is exactly what was in the middle. So what we're doing is figuring out what number can we put at the end to make this a perfect square trinomial. So we kind of use backwards intuitiveness. Whatever we put here, we have to be able to take the square root of. And we take the square root of the first one as well, which is an x. And then whatever the square root of this is, whenever I multiply it with the x, and then I double it, I get an 8x. So you're just trying to figure out what number would be here. And so that number would need to be a 4. If we multiply by 4, we would get an 8. Now that doesn't mean this is 4, that means the square root of this was a 4. So that means this number was actually a 16. Now that's the mathematical intuitiveness of how to do it, but if you're looking for just the formula and you don't want to go through all this process, to complete the square, you take half of the middle and you square it. So we would have taken half of 8, which is 8 divided by 2, which is 4, then we square it, which gives us the 16. That's the shortcut. So on 16, same thing. We're looking for the missing blank. So we have y squared minus, actually it's a v. Change that, not that it changes anything. V squared minus 18v plus something. So we take our middle term, which is a negative 18, we divide it by 2, or multiply by 1/2, same thing, gives you a negative 9. If you square a negative 9, you get a positive 81, which is why we put a plus sign in front, plus 81. Now, the whole reason we do completing the square is because they're the easiest things to factor. For example, if we take a look at the last one, v squared minus 18v plus 81, if you were to factor this, a diamond does work. What adds to give you negative 18 and multiplies to give you 81. That would be a v minus 9 and a v minus 9, which we write as v minus 9 squared. If you look at the other one we did, which was x squared plus 8x plus 16, and we go, well, what adds to give you 8 and multiplies to give you a 16? That's a 4 and another 4, which we write as x plus 4 squared. Well, as mathematicians did this over and over, they said, look, your factored answer are just your square roots. v9, v9, square roots, x and a 4. The only thing you have to remember is whatever sign's in the middle, that's the sign you put in your answer. So this was a minus, so we put a minus in the answer. This is a plus, so we put a plus in the answer. So that's how we factor these so quickly. We just take their square roots, which is what is helpful when we go to question 17. And it wants us to complete the square to solve these. Because what we would have to do, this can't be factored. We could do the quadratic formula, but as we see, that takes a little bit of time. So instead, we're going to turn it into something that we can factor. And we're going to do that by changing the way the equation looks. We're going to put our own number here. But we want to put a number that's going to be easy to factor with. And we just learned that for those perfect square ones, to factor them, you just take square roots. So that's what we're going to do. We're going to complete the square. We're going to find a missing number here. So I'm going to take my negative 6 divided by 2, which gives me a negative 3. And I'm going to square it, which gives me a 9. Now this 9 I just came up with out of thin air, so to speak. So if I put a 9 on the left, I've got to balance out and put a 9 on the right, because this was brand new to the problem. So if I put it on both sides, I still have a true statement. Now here's the beautiful thing we can do. We can now factor this. And we know to factor these, all you have to do is take the square roots. So we get x minus 3 squared. 19 plus 9, which gives us a 28. Now we're back in business because now we only have x's. So let's just play the game of opposites. So to get rid of that squared, we do the opposites. We take the square root. So we have x minus 3 equals plus minus square root 28. Now to get rid of that 3, we add 3 to both sides. So you have x equals 3 plus minus square root 28. So that means you have two answers, and this is where you'll need your calculator. You're going to do 3 plus square root 28, which rounded to the nearest tenth gives you 8.3. And then you're going to do 3 minus the square root of 28, which rounded to the nearest tenth gives you negative 2.3. Let's try that process one more time on 18. So in 18, we have j squared plus 10j minus 3 is equal to 0. So if we tried to factor, it wouldn't work. Nothing adds to give you 10 and multiplies to give you a negative 3. At least nothing that is a whole number or an integer. So we're going to get, we can't do those. So we could do the quadratic formula, which you're more than welcome to do if you want to, but I'm going to do the completing the square. So I want to put my own number here. I don't want to use this minus 3. So I'm going to get rid of that guy and put him on the other side. So now I have j squared plus 10j equals 3. So now to complete the square, we've learned that you take half of the middle and then square it, which is 25. So the 25 was not in the original problem, so if I put a 25 on the left, I have to also put it over on the right. Now the beautiful thing is I can quickly factor this because I know it's a perfect square trinomial. So I just take the square roots and I get j plus 5 squared is equal to 28. Now we just play the game of opposites. To undo squaring, we square root. So j plus 5 equals plus minus root 28. To get rid of that plus 5, we subtract 5. So j equals negative 5 plus minus root 28. Now you use your calculator. You're going to do negative 5 plus root 28, which gives you approximately 0.3. And then you're going to do negative 5 minus the square root of 28, which gives you approximately negative 10.3. You would have gotten these exact same answers with the quadratic formula, but this is just a little bit quicker to most, not to everybody, but to most that's the quicker method. Alright, for 19 and 20, we're going to change from standard form to vertex form. So remember, vertex form is y equals a x minus h squared plus k. So if we get the vertex coordinates, all we got to do is also then get the a value and we're done. So let's take a look at our first one. It's y equals, actually it's f of x equals x squared plus 12x plus 36. So I already know one thing right away. This a value is equal to a 1. So in my final answer, I automatically know that a 1 goes in front. Now you don't have to put the 1, but I'm putting it there just so everyone knows that's where it came from. All that's left to do is get the x coordinate and the y coordinate. So we use our vertex formula. Vertex ends in x, so negative b over 2a. So it's going to be a negative 12 because your b value is equal to 12. Negative 12 over 2 times 1, which gives me a negative 6. So my vertex so far is negative 6 comma something. Well, to get that something, we're going to put the negative 6 into the equation to get the y value. So f of negative 6 is negative 6 squared plus 12 times negative 6 plus 36. So f of negative 6 squared is a positive 36. (12 times negative 6 is going to give us a negative 72. So now we subtract. 36 minus 72 gives us negative 36. And actually, I needed to change. It's not 36 in the question. I wrote down the wrong part. It's not going to change anything we've done so far. Let me fix it for people who are doing the notes. This is x squared plus 12x. It should be a minus 32. Sorry, I wrote that down wrong. So minus 32. So then these turn into minus 32. Minus 32. Minus 32. And negative 36 minus 32 gives us negative 68. So now we've got the y value. So the x is a negative 6. Remember, in the equation, there's a minus sign, which means use the opposite. So the opposite of negative 6 is positive 6. With the k, there's a plus sign, which means use the exact value. The exact value is a negative 68, so we write minus 68. And that is your final answer. The 1 does not need to be written down if you don't want to write it down. Number 20, same thing. X squared plus 3x plus 1. Well, I know that the a value is equal to 1. So I now know it's 1 parentheses x something in here squared. So now we got to do negative b over 2a. Our b is equal to a 3, so this becomes negative 3 over 2 times 1, which gives us negative 3 over 2. We now have the x value. If we want the y value, we plug this in. So y equals negative 3 over 2 squared plus 3 over 1 times negative 3 over 2 plus 1. When you multiply a fraction by itself, you just multiply the top numbers and the bottom. So negative 3 times negative 3 would be a positive 9. 2 times a 2 would be a 4. So that's 9 fourths. 3 times negative 3 is a negative 9. 1 times 2, so this is minus 9 over 2 plus 1. Now we need common denominators, so we'll use 4s as our common denominators. 4, 4, 4. This stays the same. The 2 was doubled to make a 4, so we doubled the 9 to make an 18. The 1 was quadrupled to make a 4, because this was really 1 over 1. So we do the same to the top, quadruple it. So 9 minus 18, which is negative 9. Negative 9 plus 4 gives you a negative 5. So you get negative 5 fourths. And that is your y value of the vertex. So now we got to plug it in. We don't use minus 3 halves, we use the opposite. So plus 3 halves. We do use the exact y value. So minus 5 fourths. Note 21, if you end up with the negative, what does that tell you about the solutions? So the discriminant is what we end up with under the root sign. So for this question, it says if you get a negative, what does that tell you? Well, that means there are no solutions. But maybe on the test, I'll say what happens if you end up with a positive. Well, if that happens, then we say that there are 2 solutions. Because when you take the square root of a positive, there's the positive answer and the negative answer. Or I might ask you what happens if you end up with a 0. In that case, there's only one solution. Because even though there's a plus minus sign in front of here, positive 0 and negative 0 are the exact same thing. So you only get one answer. 22 says, using the discriminant, how many x-intercepts are there? So again, we don't care what they are, we just want to know how many there are. So we care about the discriminant, which is the b squared minus 4ac. That's the part under the root sign. So a is equal to 8, b is negative 2, c is negative 3. So b squared would be negative 2 squared minus 4 times a, which is 8, times c, which is negative 3. So now we do order of operations. Negative 2 squared is 4. When I multiply, I like to use that minus sign. So negative 4 times 8 times negative 3 is a positive 96. Since it's positive, I write plus 96, which means I'm going to get 100. If I take the square root of 100, I will have 2 x-intercepts because you have the positive and the negative. We have to find the equation of the parabola in standard or vertex. I would strongly encourage you to do it in vertex form. So to do that, you have to find the vertex of the picture. So if you look at your graph, the vertex is located at 1, 3. So you automatically have half of your answer. Y equals a, x minus 1 squared plus 3. But here's where you have a little bit of a problem. You can't leave an equation with a random a there. So you're going to have to figure out what a is. And the way we do this is we plug in a point from the graph. Because remember, the picture you're looking at in front of you, it came from the equation that you are making. So the numbers have to work in here. So let's pick a nice easy point. I see the point 2, 5. So 2, 5 had to come from here, which if it did, that means the 5 was the y, the x was the 2. So let's see what we get. So if we do our process for solving for our variable, we would get 5 equals a times 2 minus 1 is 1, and that's 1 squared. Well, 1 squared is simply just a, 1. And 1 times a is really just a. So now, what plus 3 gives you 5? Well, that's got to be a 2. So we now know what a is. A is equal to a 2. So we go back to our equation. Now we don't just put in a here. We get rid of that a, and we put in what we just figured out it was, which is a 2. And now we have our final answer. If you wanted it in standard form, just in case anyone did it in standard form, you started with 2 parentheses x minus 1 squared plus 3. So you could have just stopped here. If you decided to keep working, that's fine. You would have had to expand this out, meaning you're going to have to figure out what x minus 1 squared is, which is really x minus 1 times x minus 1, which, if we multiply it through, that gives you x squared minus 2x plus 1. Now you distribute the 2, so 2x squared minus 4x plus 2 plus 3. Now you combine like terms, so 2x squared minus 4x plus 5. If you wrote it in standard, that would have been your answer. Alright, word problem, you're going to have to look on your paper for this one. They give you an equation where h is the height, and they say t is time. So t is time, and h is equal to height. And they want to know how long will it take for the screwdriver to reach the ground. So you've got this screwdriver that's falling down to the ground. Well, when it hits the ground, we know what the height of that screwdriver is. The height has to be 0 because it's on the ground. So you have an equation where you can put in height numbers. So let's put in the height value of 0. 0 equals negative 16t squared plus 98. Since it's just t squared, we just do basic game of opposites. We subtract 98 from both sides. We then divide both sides by negative 16. And 98 divided by negative 16, this is where you'll need a calculator, is 6.125. Then we take square roots, and we get our final answer rounded to 2.5. So it took approximately 2.5 seconds for the screwdriver to fall from where we dropped it. And we dropped it at a height of 98 feet. That's what this plus 98 means. It means we were 98 above the ground before we dropped it. And finally, 25, 26, 27. If we start off with g of x equals x squared, we want to know how did things change. And these are the same rules that you can look at the old study guides and notes for function shifts and absolute value shifts. Nothing changes. So if we look at g of x equals x plus 5 squared, since this number is the one with the x, it controls the horizontal shift. Because horizontal has an O, that's a helpful way to remember it's the opposite number. So instead of plus 5, you would think right 5, it's actually the opposite of right 5. That means it was a left 5. And even more detailed is because the vertex of the original graph is 0, 0. The vertex of this one, if we were to write it, is negative 5, 0. So we moved it over 5 to the left. If we look at 26, where they have x squared minus 29, the vertex for this one would be 0, negative 29. Well, that means you have gone down 29 from the original graph. And finally, the last one, which is g of x equals negative on the outside, x plus 3 squared plus 82. If we were to write the vertex is negative 3, 82, which means you went 3 to the left, you went 82 up, but here, this negative sign takes your regular smiley face parabola and it now makes it go in the opposite direction. we cannot say flips upside down, or we can't say it makes it go down. Instead, we say it reflects over the x-axis. And that would be your final answer. And that is the final question of the study guide. I hope this helped.